There's this instrument called the pyrophone, which is basically a fire-powered organ, and it shoots fire when you play it. So I thought, why not build a ukulele that shoots fire when you play it? So that's what I'm gonna do. Alright, here's the plan. I have a cheap crapalele with a pickup. I'm gonna extend the neck and mount a can of butane to the extension. I'll plug the ukulele pickup into a sound sensor, which will determine how loud I'm playing. You know, music is very dynamic, so I want little flames for quiet notes and big flames for loud notes. The sound sensor will send that loudness information to an Arduino. An Arduino is pretty much the brains of this entire thing, so think of it as a mini computer. Well, actually, the one I have is not technically an Arduino. Arduino's the name brand, and I'm broke, so I bought the Chinese knockoff that's cheaper and does the exact same thing. I don't actually know what it's called, so let's just call it an Arduolingo. I'll write some code to tell the Arduolingo to take the loudness input and move a motor based on the loudness, which will trigger the butane. But that's easier said than done, so let's start building. I'm gonna extend the ukulele neck with some overpriced wood from Michaels. I designed a basic rail system for the butane to travel on and cut it out with a CNC machine. So I used some bearings to make a sort of butane roller coaster. This metal bar at the top is what triggers the butane. I just put the tip through the hole and hit it from the back to make it squirt. Now I have to wire up all the electronics and write some code to make sure everything works. I'm gonna explain some of my code. This is usually boring, but trust me, I made it interesting for the YouTube content. Actual comp sci majors are probably gonna have a stroke reading my code, but I don't care because my code works. So there's this variable. Call it whatever you want. I called it Katara. Yip yip. I made my code avatar themed because my ukulele is essentially a firebender. Anyways, that variable, Katara, yip yip, is constantly changing every 100 milliseconds or every 10th of a second to measure how loud I'm playing. Normal people would probably use decibels to measure sound intensity or loudness, but my cheap sound sensor can't measure in decibels. Instead, I made my own superior system that measures loudness on a scale from 69 to 420, where 69 is no sound and 420 is ear rape. So if I upload my code, you can see how the audio spikes every 10th of a second to a number between 69 and 420, just based on how loud I'm talking. That information is sent to the motor so you can kinda see it vibe along to my voice. And why do I check loudness every 10th of a second? Well, I need a short amount of time for the motor to move from one position to another. The motor moves based on loudness, meaning it has to move up to 10 times per second, and that's about as fast as my motor can move. If I use a slower interval, it would put less stress on my motor, but there would be a long delay between when I play and when the motor moves. So I think a 10th of a second is a good compromise that doesn't jack off my motor, but short enough where there's not too much of a delay between when I play and when the fire sprays. Now that I know that all the electronics work, I don't actually want to use the microphone that comes with the sound sensor. Microphones pick up all sounds, so it can hear the ukulele play, but it can also hear me talk, it can hear the motor move, it can hear my dogs bark, it can hear my neighbors clapping cheeks, and as you can hear, all that background sound clouds the signal. Microphones can't distinguish between ukulele sound and background sound, so instead of trying to distinguish the two, I can just give my microphone a little snip snip vasectomy and solder on a 1/4 inch input. That way, I can plug my ukulele pickup directly into the sound sensor and background noise will not affect the signal. So now, as you can see when I talk, the audio doesn't spike, but when I strum my ukulele, the audio spikes somewhere between 69 and 420. Now I need a way to ignite the butane, because I can spray it all I want, but it won't make a flame unless I ignite it. Most people would probably use a gas lighter, but I decided to use an electric arc lighter because it's easier to control with my Arduolingo. Unfortunately, the manufacturers of these arc lighters are smart because literally every arc lighter on the internet has an auto off feature that shuts it off usually between 5 to 10 seconds. It's a safety precaution to prevent dumb people from starting fires, which is good for humanity, but bad for me because I need a sustained arc to ignite the butane. Instead, I bought this arc generator, which would basically do the same thing as an arc lighter, but have zero safety features, which is great. The only problem is that the arc generator just has 2 wires sticking out, and that's a little too sketchy, even for my standards. So what I'm gonna do is take this arc lighter with a nice semi-erect shaft, unscrew the body, gut the innards, and solder the 2 leads from my arc generator to the 2 leads in the shaft. That way I can make an arc lighter with zero safety features and still be able to control the arc by moving the shaft. Now the arc generator is pretty battery intensive to run all the time, so I need a way to control it. I want it to turn on when it detects sound so it can ignite the butane when it triggers, but turn off when there's no sound to save battery. Luckily that's pretty easy to do with my Arduolingo. I just need a relay, which is basically an electronic switch. Then I can write some more code that says when there's a sound level above 69, which is any sound, it will trigger the arc generator for 1.420 seconds and then shut off. I'm gonna run a quick test to make sure my code actually works. When I strum my ukulele for less than 1.420 seconds, you should see the arc lighter ignite and the motor move in short intervals. When I strum my ukulele and sustain the sound for more than 1.420 seconds, you should see the arc lighter ignite and shut off after 1.420 seconds, all while the motor continuously moves. It looks like everything works individually, so I just need to put all the parts together and hope it works as a whole. The butane can actually has a concave bottom that the motor arm perfectly misses, so I quickly designed and 3D printed a little piece that would connect the motor arm to the butane. Then I sprayed the entire thing with some fire retardant spray cause, you know, wood and fire don't really mix well. And that's pretty much it. Here's the Flamethrower Ukulele. So that's it for this video. I'm never gonna play this again because it's super sketchy and I'll probably end up catching something on fire. The top also got a little roasty, so I don't think it lasts much longer anyways, but you should still like and subscribe so I can afford to build more stupid ukuleles in the future.